Don't make me yell at you in the first row. Okay. This was the homework that I posted on Canvas. I will be going over this document. I cannot solve each and every problem, but I'll try to solve the difficult ones and the important ones. That's why the video, so you can watch it. Yeah.
Then we at least know how to do a couple as opposed to like only kind of understanding some of like a couple things.
Okay. Okay, good.
Can we do
Yes, we will do implicit differentiation too. Okay, look. This is exam 2. Exam 2 review. I should not hear any of you talking, especially the ones in the second row. Exam 2 review. This is for MAT210. Third, my bad. MAT210. Okay, I'm talking about chain rule section 11.4 first, because that's going to be on the exam. This is chain rule. Topic 1 on your exam review. 11.4. The question that I have marked is number D here. So that's important. Number D. So you have to find dy over dx. The question is find y prime, where y is given to be 25 over, and I have a quadratic x squared plus x plus 2 raised to the power 4. So this is the question. This is the chain rule topic, and I'm supposed to find this derivative. Well, first things first, I see that I have a fraction. Do not apply quotient rule here. Do not do quotient rule. This is easier than you make it. Well, first, I want to make it a power. So how do I write? See, I'm not applying any formulas here. I'm just rewriting the question. This is x squared plus x plus 2. And because I'm moving the number up, only the power becomes negative, nothing else. The power becomes negative. If there was something in multiplication here, some number, that would stay in the bottom. The power becomes negative, and now I can apply power rule. So apply power rule with chain rule here. Apply power rule with chain rule. And this is exactly how many steps I want you to do in exam. So y prime will be, well, 25 remains as it is. Nothing will happen to 25. You take the power out. So that would be negative 4. Copy the inside as it is. Subtract 1 from the power. So negative 4, subtract 1. We're not done here because the inside is not just x. So there is an extra step. What is that extra step? Multiply by the, just don't forget the extra step, okay? So I get 2x plus 1. Now you can leave it here in exam. No need to simplify. I mean, just leave it here. Negative 100. It's up to you if you want to move the negative power back to the denominator. Even if you don't do that, I'm good. Okay, this is acceptable for full credit. Good question, yes. 25 is in multiplication. Stays as it is, right? I just moved the fraction up. Good?
Oh, okay. So instead of having like the you didn't multiply by 4 twice.
Yes. Good. Okay, 11.5. Next topic is, now you will get log and exponential derivatives in this exam. So you must remember those chain rule formulas too. Question, Frank. No what?
No card.
Will
No
you give
card,
us
a
something,
no
will you
card.
have no cards?
No, there is no cheat sheet. That rule is consistent for all 210. I cannot change that. No, it's not allowed for any course. Okay, second topic. Do you want me to finish this review? Because if it's not, then don't ask me exam related questions. Derivatives of log and exponential functions. Log and exponential functions. This is 11.5. 11.5. Okay. Now, I have picked two questions from this section which are important. Number C. So if you go to your exam review, I'm talking about part C here. The question is, well, again, you have to find y prime. That's not going to change. For C, the question is natural log, and you have x cube minus 8x. Okay. And I want to find this derivative. Everybody remembers, let me just make a little recall. What is the derivative of natural log? 1 over x. Good job. What is the derivative of exponential function? Just the same thing, right? Now don't forget this, because this will also be used later on when you're doing the applications part. But if I have something else inside the log, I just multiply by the derivative. That's the chain rule, right? In this case, I just multiply with the derivative 1. Okay, let's solve this problem. So I have y prime. I apply the log derivative. So anything that is inside the log will go down to the denominator. That's the formula, but it's not just x. So I will multiply by the derivative of the bottom, multiply. So what is the answer here? Yeah, over this. Good job. So this is it. So that was the first question that I wanted to do. And the second question is number I of the same topic, number I, which is y equals 5 times e to the power 3x cube plus 2x. Okay. Now we know that the derivative of e to the power x is just e to the power x. But if there is something other than x, you multiply by its derivative. That's the only extra step. Okay. So you copy e to the power that as it is, and what do you get? So you get y prime. 5 remains, nobody touches the 5. Copy e to the power 3x cube plus 2x as it is, because that's the formula. But I have to do one extra step. What is that? Multiply. And what is the derivative of the power? Oh, good job. And that's it. Expect questions like this in the exam. Nothing crazier than this will show up. Yeah. Later on, let me cover the whole thing first, because I don't want to miss the topic. But I will do questions if I have time. Implicit differentiation. There is no J. Okay. Oh, G you meant. Okay, let me just quickly do number G, because that's what Ali wanted. Y equals e to the power 5 over x. Okay. I want to find y prime. Well, first things first, what is the derivative of 5 over x? No. How do you have to make it a power first, right? Then take the power out, subtract 1.
What?
Just differentiating it. Did you not practice this topic? I assigned this for homework. Okay. You got this answer as it is? Exactly. That's it. Just remember, if you have a fraction, you make it a power, and then it should be power rule. Don't panic if you see a fraction. All you have to do is make the x as a power, move it up. Only power becomes negative. Now, implicit differentiation. You will get a question or two at most on the exam doing implicit differentiation. Okay, this is 11.6. Implicit differentiation. Just follow the steps. Every question will be similar. Now, you have to know formulas for product rule, but you already did those problems in exam 1. I have picked part B here. Part B is implicit differentiation question will look like this. You have to find dy over dx, and the question will be, they will give you an equation. For this case, I have 6x squared y negative 15x equals y squared. Now, the major mistake I've seen you do in the review quiz last Monday, or was it Wednesday? I forgot. That you just do the product, you see one big term and you apply the product rule, everything is correct, but then you completely miss these two. So don't miss anything. You have to differentiate each term. Just keep this in mind, differentiate each term. That's what I'm seeing a lot of you make this mistake. You apply product rule and then you forget about the other two terms. So you have to differentiate everything. So look what's going to happen here. I have three terms. How do I differentiate the first term? Yes. Product rule. Good job. Yes. Doesn't matter. Product rule, pick anything. The first function is f, the second function will be g. Okay, that's what I'm doing now. Okay, so but you understand that you have to do product rule here, right? Now the question is, what is the f and g? Now it's up to you. So this function is going to be f and this function is going to be g. This is exactly you copy step by step in exam. You will see a question like this. Okay, what is f? 6x squared. What is g? Just y, right? What is f prime? 12x. What is g prime? Don't say 1. Y prime, you have to find y prime, right? Do not forget the y prime whenever you're differentiating y. Same thing, yeah. And now this is just for the first term. Okay, let's talk about this term. What is the derivative of 15x? Just 15, good job. And what is the derivative of y squared? Power rule, you take the power out, subtract 1, but every time I'm dealing with a y term, you multiply by y prime. Good. Just make sure first step, differentiate, do exactly the same. Now apply the rules. So the product rule is, what is a product rule? Yeah, you must know this, okay? So multiply this, what do you get? F prime is 12x, g is just y, g prime is y prime times f, so I get 6x squared y prime. That is just for the first term. It cannot be this small. These questions are lengthy. If you have a small answer, you're making a mistake. The second derivative was just 15. And on the right hand side, when I differentiate, I get 2y prime. And that's one more way to check your answer. You will have at least two terms involving y prime. You will have to group them, take the y prime factor, and then divide by it. If you have one term involving y prime, you are making a mistake. See, I made a mistake here. I had to multiply by y prime. Good job. That was a test. If you have one term of y prime, something is wrong. Now next step is just algebra, move all y prime on one side, all y prime on one side. So when you do that, you should get this. So the 12xy and the negative 15 will remain on this side, and the y prime term, which is the plus 6x square, will go to the other side. Good? Yes, question.
Why for like the, 2y times y prime, why did you have to multiply it by y prime?
Chain rule.
But why?
What is the derivative of y? Y prime.
Yeah.
You always multiply, but just remember that, okay? You multiply by y prime. Good. Now, take factor y prime out. What do you get? Okay, good job. And where did you get the y? Good, good. Okay. And last step is just divide by it. Now I have given you plenty of chances to practice this. I can't even remember how many quizzes I've done with implicit differentiation. I expect all of my students to get this right in the exam. I have spent much time on this. So I get y prime equals 12xy negative 15 over 2y minus 6x squared. And that is it. This is it. Follow these steps. Yes. Evan.
So we're from 12x, y minus 15 to
Yeah, this thing.
taking the y prime out. 12x, y minus 15 equals y prime, then parentheses, 2y squared. How do you get the answer you got?
I divided by it. The whole job is to isolate y prime, right? That cancels out. Just like you isolate a variable, you're isolating a variable called y prime. Okay, watch this video again. I'm going to move on. Okay, now the next section is where you have to understand the conceptual part. Okay, now 3 things I want you to memorize. For 12.1, it will be a true false or MCQ problem, but you just need to understand the conceptual part. Okay, so 12.1 will be MCQs and true false. So like just read my lecture notes. Okay, 12.1. This is maxima and minima. 12.1. 3 things I want you to know for true, false, or MCQ question. What happens when f prime of x equals 0? Just know that for conceptual. What will happen to the graph? The tangent at that point will be 0. Tangent, not at that point, will be horizontal. Okay, if they ask you something like this, just know what you're trying to look for. Second, if your f prime x is greater than 0, what does that tell me about the function? Increasing. Good job. F of x is increasing. So they'll give you a true false question. Just know what it means, right? Understand a little bit of concepts to answer this. What happens if similarly, if your derivative is less than 0, I will post these notes, so no need to copy. Is decreasing. Good. What type of sad face or happy face you should see on the graph for a relative max or min. Just the conceptual part here, okay? If you see something like this on the graph, then what is that critical point? No, not absolute, relative max. Right? Remember this, okay, for the true false. If you see something like this happening on your graph, what would that point be? Good job. Now let's talk about, well, that's it. Just remember that, okay? Now we come about finding these points, right? Oh, we're still in 12.1. Now, how do I find this? So I have picked an example number 5 from this topic. Now, this will be an expensive question, but it will be divided into subparts so that you can get partial credit. Okay, so it will have multiple parts, derivative. Everybody should be a master of differentiation by this point. Okay, I'm picking number 5, and we're going to follow the exact steps that I'm doing. Number 5, 12.1. F of x is given to be three x to the power 4 plus 4x cubed negative 12x squared. And if you notice one thing, they have also given you the endpoints of the interval. It's -3 to 0.5. This is all given to you in the question. Now, there are 3 points that they want you to answer. Everybody should know how to find critical points at least, okay? How do I find critical points? Not that function, the derivative, right? Finding critical points, you first differentiate the function. Well, this is a polynomial. It's like easy peasy to differentiate. Right? And to find the critical points, I have to make this a 0 and solve. Practice this. What do you get? You take 12x common, yeah. Okay, who's going to factor this for me? Oh, God. Wait. Yes, so you should get a 2 here. That was again a test for you guys. Good job. No. You have like -24. Am I giving an exam here? -2. Who's going to factor this for me? Okay, I see one hand. You can also use the quadratic formula. Casey, what are the 2 factors? Okay, I need faster. Yeah. Oh, you're doing quadratic formula? No, I want somebody to give me the factors. Yes, I forgot your name, but yeah, I see your hand. X plus 1, x minus 1, and x plus 2, right? Who got the same factors? Or use quadratic formula, up to you. Yeah, for this part. Now, I will not give you the quadratic formula in the exam, so you have to memorize this one too. So I've got 3 factors, right? Look, I have a cubic polynomial. So I should have 3 critical points. So I got 3 critical points. I got x equals 0. I make all of them 0 and see what I get. Right? So I got x equals 0, x equals 1, x equals -2 are the critical. What happened? But because it is still a factor, right? It has an x. That's important. It still matters. If it was just a 12, yes, you could get rid of it. But there is an x, so it is a factor, and I should get 3 critical points. Good. Now here comes, after this, things get a little tricky. Now there are two things that you'll see in the exam. Now focus here. You'll be asked to find the relative extrema and the absolute extrema. Now do not confuse these two processes. Okay, every question will be the same until you find the critical point. You differentiate, make it 0, you find a critical point. After that, we have two separate methods. So there will be two things that I'll ask you to find in the exam. First will be your relative. Now there's a difference in these 2 points, extrema, and the other thing that you'll find is absolute extrema, right? You have seen this term before. Now there are two different methods to find it. For relative extrema, I will draw a number line. I will use my interval that is given to me in the question, and I'll separate it with the critical points. So plot your critical points here. -2, I got 0, I got 1. Right? 1 is not even in the interval because they only want the interval to 0.5. Well, we will still plot our critical point. Ignore that. So I have your critical point 1. Okay, let's just make it infinity to infinity.
Wait, but how did you just change the question?
I didn't change it. I just plot the critical points.
I thought you said that two outside one was supposed to be like the one who started.
Yeah, ignore this. So what if you're not given the interval, right?
So you can ignore it?
Yes, for relative extrema. Okay. You see the two things I'm finding for relative and absolute. I'm only talking about relative extrema so far. I only care about the critical points. Yes. There you go. Good. Happy now? Okay. Now, what is the next step? How do I find the positive, negative? Pick a test point. Yeah. Pick a test point on each interval and calculate and check the sign of the first derivative of f prime, right? That's what we do. So you pick whatever you want. Let's just say I pick a test point of, now just memorize this. You have to do this in the exam, okay? Pick a test point, pick a big number, -10, okay? In this interval. And I'm gonna pick a test point, say -1 here. Pick a test point of, say 0.5. Pick a test point, say 10. Now plug this in your calculator. All the test points, what do you get? Now I wish I had solved this question beforehand. Somebody give me the answer.
But you're putting that into the 12x cubed.
The derivative, yeah, this one. So if I plug in -10, this will be negative, this will be negative, this will be negative. So I'll get a negative at the answer, right? -10 will give me a negative answer. If I pick -1, I'm just plugging it in. -1 is going to be positive. I get positive here. If I pick 0.5, so this is going to be positive, this is going to be positive, negative. So I'll get a negative here. If I pick 10, so positive, positive, positive. Okay, so everything will be positive. But you can just quickly plug all the numbers in your calculator. And now I draw the signs. So in this case, my derivative is negative, my derivative is positive, derivative is negative, derivative is positive. And there you use the phases, the behavior of the function. So what do I get? It's decreasing and it's increasing. It's increasing and it's decreasing. It's decreasing and it's increasing, right? And that gives you your relative, max, and min. All of this work for relative, not for absolute. Remember this, because we'll be using it for 12.2 also. Relative is a lot of work. You have to draw the number line. You have to do all these steps. They're not difficult, but it's just a lot of work, right? Just plugging in your calculator is a lot of work. So memorize these steps. Okay, I'll post these notes. So what about my x equals -2? Is that a minimum or a maximum? Is a relative min. What is the function value at -2? Well, plug in it in your function. What do you get? What about x equals 0? We only care about the critical points, right? Is relative max. And x equals 1 is again a relative min. And what is the function value? F of 0 will be 0. And 1, plug in your f of 1 here, see what you're getting. Now for absolute, the work is reduced exponentially. You'll see in a minute. In the actual original function, f, not f prime. Question. For absolute, yes. For yeah, that's what we're going to use for the absolute function. Okay, we have to categorize our critical points as a relative max and min. But yes, you could ignore 1 here, but I just want to make sure that every question is same. For absolute extrema, it's going to be easy peasy. Just plug in the critical points and end points in the function, and that's it. Okay, so plug in the critical point. What do you get? I had 3 critical points, 0, 1, and the endpoints were -3 and 0.5. And tell me what you get. In the original function, f means the original function. Well, whichever is the max will give you the absolute max, whichever is the min. Bruno.
So for the relative window, technically we would do x.
It doesn't fit in the domain, I know. Let's just say I make it 2.5, just avoid the confusion. What if it was 2.5? Now, for the online version, who's going to find all these values? Nobody's working on their calculator. You have to do this in the exam.
Oh, we're trying to rate one, maybe we're.
I will post these notes. Okay, so I'm just going to write it out. So you are plugging it in the original function, -12 -2 squared. And tell me what's the answer. 0 will just be 0. 1 will be, we'll plug the 1 in here. 1, 4. No, you don't have to write all that. You just have to plug it in your calculator and give me the final answer. And -3, plug it in here. So same thing, right? And whichever is the max, who's going to tell me the max now? And say 2.5, I plug it in the function. There you go, right? Whatever is the maximum point will give you So x equals nobody? What is the max, absolute max? Which of these is the maximum? Do you have the answer? Yeah, what is the answer? Oh, so you got -3 is absolute max. Yeah. So that's right. So -3 and the function value is 27. Right? That's how you write in the exam. Sometimes 2 points will give you absolute max. So that's also correct. What about the minimum? You should get negative somewhere too. -2. And what did you get the absolute minimum value?
Oh, yeah.
-3. 32. Okay, that's good. So there you go. So just remember the 2 steps. For absolute extrema, you find your critical points and your endpoints given in the question, plug it in. That's it. For relative extrema, that requires more work. Then you have to divide your number line, plug in your critical points, check the happy sad face. But don't confuse these two. Okay, they're 2 different things. Question. Can you find what? On a graph.
First two things, 12.1, we do a graph. And, I think he's asking, how would you find it on 12.1?
So that's what you see, right? You look for the happy face on the graph. That's your critical point right there. Absolute max will be, well, in exam, they will give you an interval. So according to that interval, the lowest point will be your absolute min and the highest point will be absolute max. But in exam, if I give you a graph, that will be MCQ or a true false. Okay? But this questions where you have to show a lot of work is what I want you to practice more. Good. No, you will not get that in exam. No, you won't get that. No. Now I want to talk about some of the problems that involve finding the critical points, but are not very straightforward. Yeah. Yes. Yes. No. No splash paper is allowed. Yes. Quick. Yes. How many? Okay, let's just focus on this.
We want to know.
Just like last exam, 10 or 12.
You don't have like another sheet of paper you can write on.
Do you want me to finish this review or not? How do you find the critical points of this? Yeah, it's number 6. 12.1 still. Nobody has printed the review, right? Then read, okay, numbers, how do you find the critical points?
This is what he was talking about on the graph.
Yeah. Okay, what do you get? Now be careful. If you get a question like this in exam, the critical points, this function will never be 0, but it will be undefined. Frank, eyes on the board. Both of you. Yes. How do you, this function, if I move it to the bottom, it will be 2 over all that, right? It will never be 0, but when is it undefined? When this function will have a 0 in the bottom, when x equals 2. So that's the critical point. Just remember that. X equals 2 is a critical point. So don't say that this function does not have a critical point. That's going to be the wrong answer. and then you follow as usual, okay? Because when I put 2 in the in place of x, I'll get a 0 in the bottom. So either your g prime is 0 or your g prime is something over 0. Those values of x give you a critical point.
Oh, why'd you move the like x minus 2 to 1 to the bottom?
Because it's a negative power, right?
I
How do you
see.
solve for the like some number, non-zero number? Right? So I just wanted to talk about this function because you might make a mistake in exam. And similarly, I want to talk about number 8 on the same page because that critical point is also complicated. Like some of you just might not practice that. So h of x is given to be ex negative x. Now, how do I find the critical points if I'm given this function? Just know now, if you didn't know it before, I differentiate the derivative of e to the power x is just e to the power x. Derivative of x is just 1. Now I'm solving for x, right? But I have an exponential function. What do I do? See, you know. How come? Because you showed up to my office. Right? How do I find the value of x? Natural log. So natural log. And that would cancel, because natural log and e cancel each other. X equals ln1. Now plug ln1 in your calculator. What do you get? What are you getting for ln1? 0. So there you go. So for questions like this, don't panic. You can apply natural log and be done with it. X equals 0 is a critical point. Now these are the two special functions that I wanted to talk about. Number 9 is very important, but it's just conceptual. So just make sure you know that. Now you will see questions like the application, the long problems. But long problems, no need to, okay. Every time I give you an optimization problem or a area, I want to do a vegetable patch, I want to minimize something, maximize something, all you have to do is find the critical points, plug those in. That's your answer. Okay. Okay, 12.2 optimization. Optimization. And what do I get here? Let's pick number 2. Number 2 is the important one here that I've circled. 12.2 optimization, question number 2. You are given the cost function and they want you to find x that minimizes the average cost. And in this case, I do give you a formula for average cost. So you're given the cost function, which is this, and you want to minimize, they already tell you they want to minimize average cost, which is the cost divided by x. Okay, do that. What do you get? So each term is divided by x, 2x divided by x, 4,000 divided by x. That's the average cost function they want you to minimize. What's the answer? So that would just cancel the power of 2 of x to 4,000 x to the power -1, right? Just remember that if you have x in the bottom, move it up. Now you have to find critical points, right? Remember like this, you have to find critical points. Critical points, the formula is same, differentiate, make it 0. Okay, what is the derivative of that function? Well, that just becomes 0. Equals 0, right? This everybody can do. Okay, so now we have to solve for x. What do you get? Every time you have a negative power of x, it's useful to move it to the bottom. Okay, who's going to solve for x here? I have a similar question in my lecture notes too. Well, you cross multiply. Okay, so when I cross multiply, who's going to tell me x square equals? Yes. I'm solving for x. Do whatever method you have learned before and isolate x square. What do you get? I mean, find me an answer. Who's going to divide this for me? Nobody wants to run this faster. Yeah. 200,000? Okay, how many zeros?
6.
Okay, what is the square root then? No. Okay, the answer doesn't sound right. Who's going to tell me the right answer? Really?
I thought you were times it 0.002.
No, you would cross multiply. So these two get multiply equal these two. So you would divide by 0.002 on both sides, right? Okay, so you have a lot of zeros here. Okay, so that's the answer. Now this number right here will give me the minimum cost. You don't have to show any more work in exam, okay? We don't have to check anything also. The minimum average cost will be plug in this number. Minimum or whatever the question is, average cost will be plug in the critical point, which is this number. Now I know it's a lot of plugging in the function, but you can do that, right? Yeah, whatever the answer is, that's the answer. Well, answers are also available online. It's what? So you did something wrong, right? So square root of this, yeah, that number of items will give you the minimum cost. So you don't have to plug it in because they're looking for, because they're only looking for the x here, right? They don't want the minimum cost. So it depends on the question. I might ask you the minimum cost. Okay? Yes. Question, yes. Average cost, whatever function they want you to minimize. So I went one step extra. In this question, they wanted to end at x. Question, yes. Bruno, you were raising your hand. Yes. Yes, you plug it in the C bar. Yeah, this one. Yes. Question, yeah. Oh, that's why. Thank you. So you learned the method, right? I have an extra zero, so it's okay. But I do the same thing. Okay, higher order derivatives. I just added an extra zero, but you know the process. 12.3 higher order derivatives. Well, this is just this is about the concavity and the intervals of concave up and down, right? Now, finding the second derivative. How do you do questions like this? Let's just talk about number B. Y equals 7 over x, negative 5 ln x. You have to find y double prime. What do you do? Well, you first find y prime, but for that you have to make it a power first, right? So the derivative of that will be, just take the negative one out, subtract 1 from the power. But that's just the first derivative. You're not done here. What do you do next? Yeah, first make it a power and then differentiate it again. That's the second derivative. So take the power out, subtract 1, take the power out, subtract 1, and that's your second derivative. That's it. Now this will be useful if I give you the placement problem, like question number 5. If I give you like the position vector and I say find me the acceleration, you have to differentiate again and again. Yes. So question number 5 is the application part. So you know how to find the double derivative. You are given the position function, which is 4et negative 8t square plus 3. And this is a very typical question you can expect. They will ask you find acceleration at some point. So in this case, they want to find acceleration when t is natural log of 6. Now units are important. I do take off marks if you don't express the units. So remember that. Acceleration is the second derivative of the position vector. And this also, I mean, you have to memorize. Yeah. Okay. So
Wait, the second derivative of what vector?
the position, the s vector, the s function,
Second derivative of the
position function.
second derivative of
What is the first derivative? Good job. What is the second derivative? Good job. This is velocity. And when you differentiate it again, you get acceleration. But they don't want to stop here. They want acceleration at t equals ln 6. So just plug in t equals ln 6. And you can use a calculator for that. Now, what happens if your second derivative is positive? Ah, good job. What happens if your second derivative is negative? And how do I find those inflection points? What equals 0? Second derivative. For critical points, I make first derivative 0. For inflection points, I will make inflection points. What do? I make the second derivative equal 0. Right? you will get a true false MCQ question. Just know that inflection points when the second derivative is 0, if it's greater than, then your function is concave up. If it's less than 0, then your function is down, concave down. Right? Just like if your first derivative is positive, your function is increasing. Second derivative is, first derivative is negative, function is decreasing. These are some facts that fundamentals. Should always remember this, right? Now, the most difficult and the last topic of this review is related rates. Now, that's gonna be not that easy. Yeah. Then you get the inflection points.
But I'm saying like, it's not fair to
Then, no, that's where it changes concavity, right? Just read my lecture notes. I have plenty of examples there. Okay. Related rates is going to be one question, but you will get partial credit. So at least do the first few steps. Now, I did talk about the triangle, right? Where you have a ladder, something is against a wall, you have a triangle. Every time, draw a picture. This is the first thing I want to tell you. 12.5 is the last topic in the review, related rates. My biggest advice is draw a diagram. Especially if you have a triangle in the picture, okay? If it talks about a ladder or some person, some tree, some shadow, draw a picture. Good. Related rates, whatever you call it, yeah, okay. Number 1 is the question that I've picked. It has 2 parts. So question number 1 is the radius of a circular puddle is growing at a rate of 15 centimeter per second. Whenever they talk about something growing, they are giving you the rate of change, right? That's also important for true false questions too. So they are giving you radius is growing at a rate of 15 centimeter per second. What does that tell you? That the radius is growing means it's positive. Just copy this for the exam, okay? Can everybody do this? Okay. The rate of change of radius, right? With respect to time. Because the radius is increasing per second. That's why I have positive. The rate of change. Good. They don't give you the radius alone. Number A, they want you to find how fast is the area growing. What do they want you to find? Not the area. They want to find how fast. No, what are you looking for? Tell me in math language. They're asking how fast is area changing? What are they looking for? At least you should know this much in exam. When R is 30 centimeter, what are they looking for here? Derivative of A with respect to t, they're looking for dA over dt, okay? This is what they want to find when R is 30. Now you're given this, so you will use it later. But what is the area of a circle? Pi r square. I might give you this formula in exam. Area is pi r square. What is the derivative? Are we missing something? I'm differentiating with respect to t. No. Yes, I said, right? You have to use this somewhere. Don't forget, we have to apply chain rule. So I have to multiply by. So what is the derivative? I'm going to differentiate both sides with respect to t. So I got pi. Pi is a constant. Apply power rule. Take the power out. Subtract 1. I'm not done here. And here's another hint. I have to use the dr over dt they've given. Chain rule, right? Okay. Now pi is a number. 2 is given to you. R they say 30. And dr over dt is also given to you. So how fast is the area changing? 60 times 15. What is that answer? 900, right? Centimeters square per second. You could leave the pi. I don't care. Yeah. Good. Can everybody do this in the exam? Okay, let's talk about part B now. Question. This is question number 1, but it has 2 parts. Times pi.
Times pi. Okay.
Question. dA over dt equals pi r square.
Oh, question.
Oh, that's just a question mark. Yeah.
Pi to r comes from.
I'm differentiating, right? Pi is a number, so we leave it on the side. Just like if it was a constant. And okay. Alrighty, part B, quickly, then I'm going to let you go. Part B is, I'm given the area is 80. Yeah? A is 81 centimeters square. And again, they wanted you to find dA over dt. Exam 2 is crucial for you to, that will decide your future in MAT210. Take it seriously. What is dA over dt? Again, the formula remains the same. But in this case, they don't give me the R here. They give me the area. So I have to find the R. How do I do that? I solve for R. So pi R square is given to be 81. What is R? Right? Can you find me a nicer looking number with not the roots in pi? 9 over square root of pi. Yeah, I don't want square root. I don't want pi. Can you give me a decimal? Practice with your calculators. This is a skill. You should be faster at it, especially during exams. Do you have an answer? 1.9? 1.98. Okay. So practice this, okay? So pi is same 2 times 1.98 and dr over dt they gave you in the beginning of the question. So once you do all this math, that's the answer. So look, this is just a few of the problems that I could do in 1 hour, but every question on the exam review is relevant for the exam. Make sure you solve the exam review once, twice, question. For R? Okay, it's 5.07 then. Yeah. Okay, practice this, everybody. I'll see you Wednesday. Good luck. And what's the final answer? No, I'm teaching tomorrow all day. Okay, now, Everybody good? Okay, stop share.